Unit 7, Day 4, Homework Tutorial. In today's class, we talked about angles of elevation and depression. So we're going to practice a few of those types of problems. I will work with you on the odds again, and that leaves you to do the evens on your own. Alrighty. With all of these word problems, it's best to draw a picture right away. If I were you, I would draw a rectangle to start it off, and draw the diagonal of the rectangle so that you split it into two triangles. And then, based off of that, you can determine how to set it up. So here's my rectangle. And here's the diagonal. Okay. And now read the question to make sure you understand what's going on, and that'll help you label your triangle. From the top of a vertical cliff 40 meters high, so I need a cliff that's 40 meters high. The angle of depression to an object. So from the top, the angle of depression would be this corner here. And since we've drawn a rectangle, I've mentioned that the angle of depression where it's located is congruent to this angle down here because they're alternate interior angles. So the angle of depression is 34 degrees. So that means both of those angles that I've highlighted are 32 degrees. So you might want to put those on the picture too. How far is the object from the base of the cliff? So we're looking for the horizontal distance of the right triangle. It's a right triangle because it's a rectangle, so we're looking for here, this, that's x. Okay? So again, an angle of depression is always formed with the horizon and looking downward. And then it'll be congruent with the angle down on the ground as well, so that way you can use the bottom triangle and not the top one, and it still makes sense. So based off of my angle of reference, 34 degrees, I have the opposite side, 40 meters, and I have the adjacent side, x. So since I have opposite and adjacent, I can use tangent, because tangent is opposite over adjacent. This is opposite, this is adjacent. So tangent of the angle, which is 34 degrees, is equal to opposite, which is 40 meters, over adjacent, which is x. So now that x is on the bottom, here's a shortcut for you. I am going to cross multiply like we've done in class. So I can put this over 1. But in the process of doing that, but there's a shortcut, in other words. Let me just scratch that. I can simply just say, switch these two, x and the trig function, and I would end up getting x is equal to 40 over tangent of 34 degrees. That helps out a lot, makes it a little easier. So that means I'm going to divide 40 by tan of 34. And you can put it in the calculator in one step. If you don't trust yourself to do it correctly in one step, then take it in stages and find tan of 34 first and then divide. But you can set up the fraction in your calculator, 40 over tan of 34, not tan inverse, and you would get approximately 59.30. meters to answer the question. Number 3 is next. I'm going to start it off again the same way. Draw my rectangle. And it's diagonal. To get my 2 right triangles. And now let's read the directions so we can label accordingly. A 14-foot ladder is used to scale a 13-foot wall. So a wall stands vertically. Any wall that you know stands vertically. So that means it's going to be these vertical sides on the left and the right. I can label with 13 feet. And the ladder will obviously lean up against the wall. So that means the diagonal represents the length of the ladder. So I'll label that 14. What angle of elevation must be situated in order to reach the top of the wall? So the angle of elevation is the angle formed by the ground and the ladder. So it's this angle down here in the corner. So from that angle of reference, I have the opposite side and the hypotenuse. So that means I can use sine. So the sine of my angle, which we don't know yet, is equal to opposite, which is 13, over hypotenuse, which is 14. So since I'm looking for the angle, I must use sine inverse and apply it to both sides. So x is going to equal sine inverse of 13 over 14. And now grab your calculator and make sure you hit sine inverse this time and not sine. Again, the difference between problem 1 and problem 3. Problem 1, I was looking for a side. Problem 3, I'm looking for an angle. So that's why we have to use inverse. And you need to recognize these differences as well come test day. So the angle is approximately 68.2 degrees. And notice my angles I round to one place is perfectly fine. And the sides I round to 2 places. And you label according to the scenario. If the angle, put degrees. If it says feet, put feet. Thankfully, number 5 looks like they drew us a picture already. So that's wonderful. We'll just use what is given. It says a ramp is needed to allow vehicles to climb a 2-foot wall. The angle of elevation in order for the vehicle to travel safely must be 30 degrees or less. And the longest ramp available is 5 feet. Can this ramp be used safely? So, first of all, let's find the angle, and then we can answer the question. And it's a yes or no question. So let's find the missing angle. My angle of reference is down here, x in the corner. You have the opposite side and the hypotenuse. So that means you use sine. Sine of x is going to equal 2 over 5. Since I'm looking for the angle, I know I will apply sine inverse to both sides. So x is going to equal sine inverse of 2 over 5. Now we grab our handy dandy calculator and type in sine inverse 2 over 5. And you get 23.6 degrees. Now, it's asking, can it be used safely? Safely said the criteria had to be 30 degrees or less. 30 degrees or less. And since my angle is currently 23.6, the answer is yes, it can be used safely. This concludes your tutorial on this assignment. Good luck on finishing the even problems.